Hi guys, this is Vineet and I welcome you to this video. Today's video topic is temporal tables and this is a part 3 of this video series. If you haven't watched the earlier two parts, I would highly recommend please go ahead and watch those two parts before continuing with this part. So guys, before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos. Also, if you want to get notifications regarding the temporal table video series, because there will be like 3 or 4 more parts in which this topic will get covered completely. So if you want to get those notifications, I would highly recommend please go ahead and subscribe right away. There's a subscribe button below this video. So please use that subscribe button to subscribe to my channel. So let me give you 5 seconds. Please go ahead and subscribe right away so that you cannot forget. Please do that right away. So guys, I hope you must have subscribed to my channel by now. If yes, let's proceed ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments, only do not touch any production environment or production databases. And guys, we would like to know your thoughts regarding our videos, so please do share in your comments, feedback and suggestions. We eagerly wait for your comments and would love to read the same. We have created some playlists for you to watch. Some of our popular playlists are SQL Server, Database Design, SQL Server Tables, Business Continuity, Indexing, Performance Tuning, Integration Services, and Transact SQL. The links for all these playlists are given in the video description area of this video. And if we talk about the total number of videos posted on our channel, it's more than 259 videos at present. And list is growing at a constant pace on a daily basis. We add lots of videos after some alternate days. We keep on adding the videos to our channel, so keep subscribed to the channel so that you can get timely notifications regarding the videos we are adding to the channel under each category or under each playlist. And guys, I'm including the links for this playlist in the description area, and I have a channel page link as well given at the bottom of this slide. So let me take you to my channel page quickly to show you how my channel looks like, and will give you a brief overview on how to browse my channel. This is the link, youtube.com/@master_data_science_with-Vineet is the link you can follow. I've opened this link. This is the link. Here you can find all my, first of all, you will see a section where there will be a playlist or video list specially curated for you as per your viewing preferences. You can browse through that list to view those videos. And guys, we have a search functionality here as well. So if you want to search about any particular topic, for example, I want to see all the temporal table videos. So what we can do is we can type in the word temporal over here and press enter. It will give us a list of whatever temporal tables video we have. So far we have created 2 parts of this video series, and this is the 3rd part I am covering off. And let's go to the home here. So first of all, you will see a list of videos as per your preferences, and second is the list as per the date time it is posted on my channel. So the recent video posted was encrypted backups, that comes under the business continuity section. And if we talk about this video pertains to the database design category and SQL Server tables category. So if you go towards the bottom of this channel page, you will see all the playlists created by me. So some of our popular playlists are, which is having more number of videos. There are 4 or 5 playlists. So first of all, you can look through the SQL Server tables playlist. You have integration services playlist here. You have performance tuning playlist, you have indexes playlist, SQL Server database design video library playlist, where we have more than 113 videos, and business continuity playlist also has around 51 videos at present. So this video pertains to a database design category. If you want to view the full playlist, you can go here, and similarly, let's see the tables playlist. So the reason we create playlist for you is because we think playlists are best way to learn. So if you want to learn about any particular topic, let's say For example, if you want to learn about SQL Server tables, what we would recommend is you should go to the SQL Server table playlist, which you can go through this few full playlist link that comes below each and every playlist to view the full playlist videos for that particular playlist. So SQL Server Tables has around 25 videos at present. So if you want to learn more about tables, or if you want to learn about operation with tables, what you can do is go to that playlist and watch out all the videos from starting till the end. So here we have all the videos related to SQL Server Tables posted so far. Alright guys, so this is the best way to learn. Watch out all the videos, whatever is possible for you. Maybe 5 or 6 videos in a day. If you have a lots of time, that would be sufficient. We keep on adding videos to the playlist. So in case you are reaching towards the end of this playlist and you think that there are more videos that have to come and join this playlist, please do let us know. And once you are towards the end of this playlist, we will keep on adding more videos to the playlist so that your learning can continue with us. Let me show you another playlist which is also very useful. Let me take you back one step. So there's another playlist which is quite huge and has a lot of material. So first one is the database design playlist, which is having lots of videos, like it is having more than 113 videos at present it has. If you want to learn about the database design area, which is the most common requirement for day-to-day jobs, so you can learn those database design concepts here. So again, the same recommendation is to go through the first video and go till the last video in this particular playlist to get better idea regarding this database design area. It consists of lots of videos, and if we talk about this video also pertains to the database design category, and in addition it also pertains to the SQL Server, and in addition it also pertains to the SQL Server database design category as well. So I will put this video under both the playlist, both in the SQL Server tables playlist and under the SQL Server database design playlist. Now let's get back. Another important playlist if I talk about is the SQL Server business continuity playlist. And this talk about the disaster situations and backups and restores, etc. So far we are covering the backup and restore section, so you will find most of the videos related to backups and restores. Once the backup and restore section is done, we will switch on to the high availability section. Here we will start our discussion on the availability groups. So by the time I reach that point, I would request you guys to please cover these topics on backups and restores. So far, whatever videos are posted under this category are from backup and restores. And these videos are very useful for you guys. So in case you want to learn about the disaster recovery area or business continuity area. Yeah, again, same methodology applies here. You should start with video 1 and watch till the video on the end to get a better clarity in that business continuity area of SQL Server. Now let me go back. So this is the channel page link. We have more than 730 subscribers at present, 268 videos posted on our channel. And you can subscribe to my channel from my channel page as well. So you must see some subscribe button over here. I'm not seeing because it's my channel page. That's the reason I'm not seeing that link. Let's come to today's topic, which is temporal tables in SQL Server, and let me take you to notes quickly. So in our earlier video, we had covered till demo 4. And lastly, we were discussing about how you can add versioning to the non-temporal tables. There are some remarks remaining related to that, adding versioning to the non-temporal table. So let me discuss those remarks first, then I will continue with demo 5. Let's go to SQL Server. I will copy in some code. So in the earlier video, we had created that under the adventure works, we had created the department table, which is a temporal table. So we had altered the normal table to make it temporal. This was the one we had created. It has a history table to keep track of the history rows. Now let's trigger a new query, and let me discuss some sample code with you here, and we will touch upon that. Let me add some code here. This code is basically creating a schema. First of all, a history schema. It is altering a table insurance policy it is adding some columns, basically the valid from column and valid to column, because initially the insurance policy table is not a temporal one and we are making it temporal here. So we are adding two columns, valid from and valid to, both of date time to type, and we are marking those columns as generated always as row start and generated always as row end. And we are marking those columns as hidden, and we are putting a constraint on these two columns with the default values of, for valid from column we are taking a default constraint value of system UTC date time, and for valid to column we are taking an highest end date possible in the system. We are taking this as a default constant because we don't supply value for these two columns, so this should take values automatically. And we are defining a period from clause, system time valid from valid to. This is a requirement to make a table temporal one. So we add a period statement over here, period for system time, and two parameters, valid from and valid to. Later on, we turn on the system versioning on the table and we define what is the history table that will store the history rows. So after we define this table, we get the table like this with the system versioned on table and a history table as well. So in this sample, we have a separate table, insurance policy. Okay, guys, let's continue our discussion on this topic. So I was showing you some sample code, and we were talking about that we are altering an existing table which is not a temporal one, and we had added some columns over here, and we had added the period for system time clause. Later on turned on the version system versioning and mentioned the history table as well to make this a table temporal one. So let me discuss some remarks regarding this code, so please listen to it carefully. So at here, if you take a look at this line of code, so here we don't have mentioned, here we have not mentioned that these columns should be not null columns, but by default it assumes that it's not null column. So if we mark the column as generated always as row start, it is also assumed as a not null column. So we are adding these two non-null columns to this table to make it temporal. And basically if we are adding non-null columns with defaults, so we have added a default constant to both the columns. So the thing is, if we are adding two non-null columns over here and we are defining default constraint on those two particular columns, so adding those non-nullable columns with defaults to an existing table with data. So if this existing table has a data, then this operation will call the size of data operation, and this will call size of data operation on all the editions of the SQL Server except the SQL Server Enterprise edition. And on SQL Server Enterprise edition, this operation will call the metadata operation. So let me mention that here. Altering an existing table, adding two null columns with default constraints to it. So with all the, so if we talk about editions other than SQL Server Enterprise edition, and second clause is that if that table has data, if we are using editions other than SQL Server Enterprise edition, then this operation will be called size of data operation. We can take this word square. So it's size of data operation, or maybe you can say it's a data operation. But on SQL Server Enterprise edition, this operation will be called metadata operation. Alright, so keep this theory in mind. For all the editions other than SQL Server Enterprise edition, this type of operation is called the data operation, and for SQL Server Enterprise edition, it is called the metadata operation. And if we have a large size existing history table with data on SQL Server Standard edition, so I'm taking a scenario here. If we have a large size history table, so we have a temporal table whose history table has a very large size. So for any existing, if we have any existing large size history table, and if it has data with data on the SQL Server Enterprise edition, not SQL Server Enterprise edition. So if we have a large history table and we have data on SQL Server Standard edition, let's take Standard edition, then we are adding a null column like we are doing in the below table. So guys, we are using developer edition. So in this edition, this will be a data operation instead of metadata operation. So if we have a large size history table in this version, but in this example, we have taken SQL Server Standard edition. So if we are adding any non-null columns, so adding non-null columns can be an expensive operation. whereas in SQL Server Enterprise Edition it is not. So this is one of the concepts that I wanted to discuss with you. You can take down the notes. Let me also save this script. This is basically adding versioning to a non-temporal table. Let me save it with that. All right, let me discuss a few more remarks regarding this code. So far, we are clear that on the versions other than the Enterprise Edition of SQL Server, adding non-null columns with a default constraint will be an expensive operation because it's a data operation, and with SQL Server Enterprise Edition, it's a metadata operation. It's a non-expensive one on the SQL Server Enterprise Edition. All right, let's proceed ahead. And if we talk about the constraints here, right? Constraints for the period start. So this is a period start column and period end column. So constraint for this period start column and period end column must be carefully chosen. The default for the start column specifies. So this is the start column, and here the default for the start column specifies from which point in time you consider existing rows to be valid. And second thing is that end time must be specified as the maximum value. So here we are specifying the maximum value for the end time for the datetime to precision. And basically whenever we add this period clause over here, so adding this period clause performs a data consistency check on the current table. So it will consistency check on the insurance policy table, and it will make sure that the existing values for period columns are valid. So we must have, if we must have any existing values in the valid from and valid to columns, adding this clause will check that particular table for particularly these columns for any inconsistent values. So it will make any consistency checks possible. So this will initiate any consistency checks if we add a period for system time statement. And this is essential statement to make a normal table a temporal one when the existing history table is specified. So in this case, we had created this history table earlier, and later on we have specified that this history table has to be used. There can be both ways. So there may be a situation where this table already does not exist. So it will running this statement will create that particular history table. So in case this history table exists, it will use that existing history table. All right. So in case we are using an existing history table, or if we specify the existing history table over here, and if we are enabling the system versioning, a data consistency check is also performed across both the current table, which is this one, and the history table as well, which is this one. So whenever we run this set of statement, and if we are using any existing history table, so data consistency check will perform both on the history table as well as the current table. And this can be skipped if we specify the data consistency check clause to off as an extra parameter. So while defining the system version history, what you can do here is you can specify some additional clause, like you can turn off the data consistency check to be off. So you can add this clause like this, data consistency check, which can be turned off. So system versioning on, and this bracket is not required here. You can put a comma over here, and you can set the data consistency check to off here if you want, like this. So if you specify this, and you need to turn off the bracket, turn off the bracket here as well, guys. All right, so double brackets are required here, and this is the statement closure. All right, so this is how you define the system versioning where data consistency checks set to off. So if this is set to off, then the consistency checks are not done when you enable the system versioning and defining the history table. If we are turning on the system versioning to on with the data consistency check to off, it will not perform any data consistency checks. All right, so we are done with this demo for remarks discussion. Now let's focus our attention on the demo 5, which is how you can migrate existing tables to built-in support. So guys, in this demo we will just discuss about the code syntax over here. So I will put in some code syntax over here that we will discuss. So let's go to SQL Server. Let me initiate a new query. And basically if we talk about this example, particularly migrating existing tables to built-in support, let's discuss about that. So let's go to SQL Server, and basically here we are discussing an example which basically shows how to migrate from an existing solution based on triggers to built-in temporal support. So earlier we used to have a trigger-based solution to implement this valid from and valid to columns to keep the track of version history of particular rows, trigger-based version history mechanism. But now we have support for the temporal tables. So this example shows how to migrate from an existing trigger-based version mechanism solution to built-in temporal support. So temporal tables basically makes our life easier because we don't have to use triggers anymore to keep the track of the version history. And basically here we are discussing how you can migrate a trigger-based solution to a temporal table-based solution. So in this example, let's put in a code here first of all. So let me copy a code and put it here. So this is a sample code, not the actual one. So this table does not exist. I'm just discussing this code. In this example, we are assuming that the current custom solution splits the current and historical data into two separate user tables. So project task current is the table which is storing the current data, and historical data is being stored in the project task history data. And we are making these assumptions that the current table stores the current data and the historical table stores the historical data. And if our existing solution uses single table to store the actual and historical rows, then you should split the data into two tables before the migration step shown in the full example. So in this example, we have already assumed that we were using two tables even with the trigger-based versioning mechanism solution. We are using two tables separately. But in case if we are using one table altogether, then we need to split this one table into two tables before migration can be done. So first step would be for the migration would be to drop the trigger. So in this case, we are assuming we have a trigger with the name project current on update delete trigger defined on the table, which we are dropping because we are moving out from a trigger based solution. So that's why we are dropping the trigger from the existing table. In this table, we are also assuming that we already have valid from and valid to columns. So we are altering those columns, changing the data type of those columns to date time type 2 and marking them as not null for both the valid from and valid to columns. So once this is done, we are again altering the table, the history table. So first of all, in the current table, what we have done is we have assumed that we have valid from and valid to columns. We have altered those columns to change the date time or the data type of that particular column to date time to type, and we have also marked these columns as not null. And this code is for just for the project task current table. And similarly for task history table, we have also assumed that we have valid from and valid to columns in that particular table. These two columns are in the project task history table. We have assumed that. And similarly, we are changing the data type of this column from any other type to datetime to type. And we are marking these columns as not null. And later on, what we are doing, we are altering this table and we are adding the period for system time clause here. So we are altering the current table over here. We are adding a period for system time clause with the valid from and valid to as the parameters passed to it. So this is how you make a table temporal one. So if you add this clause, this will make the table temporal, a normal table a temporal one. And later on you will turn on the system versioning on the current table. So this is the current table. We are setting the system versioning to on, and we are mentioning the history table as the project task history. We have mentioned the schema along with the history table name. And here we have explicitly mentioned that data consistency check should be on. Otherwise, by default, it assumes that it needs to run the data consistency check whenever you enable the system versioning on an existing table. So this is the code we have shown here as an example on how to do a migration. We are not actually performing the migration, but yeah, we have just discussed the code on how you can move on from a trigger based version mechanism solution to built-in temporal support. So this is how this has to be done. And let me discuss some remarks. If we take a look at code here, we are referencing existing columns in the period definition. If we are referencing the existing columns, these are the existing ones, valid from and valid to. We assumed that these already exist in the project task current and project task history table. So we assumed that this column already exists. So if we add this clause, add period for basically this clause period for system time, and if we are referencing any existing columns, it implicitly changes the generate always type 2 as row start. So if we use this line, it will automatically assume it will implicitly changes the generate always type 2 row start and as row end for these particular two columns. So this will be a row start column and this will be a row end column. So we don't here need to explicitly specify. Otherwise, we need to specify it here that it should be generated as row start. We used to mention that code, right? So the code was generated always as row start. We used to type that code, right? If you remember. All right. We used to mention this code with each and every column, except for the history table. We have to mention these two statements for the valid from and valid two columns. This is row end. We used to do like this, right? We used to mention like this, right? So if we mention this statement, there's no need to mention these statements. It implicitly considers that the valid from column is generated always as a row start column. It also implicitly changes the valid to column to generated always as row end column. So we don't have to mention it here, these clauses explicitly, in case we are adding a period for system time clause to an existing table. All right. And basically, if we are adding the period, so adding this period clause performs a data consistency check as well, as we discussed earlier. So if we add this line, the period for system time, it performs the data consistency check on the existing data, which is under the project task current table. It will perform the consistency check and it will make sure that the existing values for period columns are valid. So it will make sure that whatever values are stored in the already existing valid from and valid to columns in the project task current table, they should be valid. If we are adding the period for system time clause, it performs that consistency check. And there is a recommendation whenever we turn on the system versioning to on, we should always specify that the data consistency check should be on, right? To basically, and we mentioned this statement to basically enforce that data consistency checks on the existing data both in the project task current and the project task history table. So your data should be valid in the valid from and valid to columns. And if hidden columns are preferred, what we can do is we can mark the word hidden along with the columns. So here after non-null columns, we can specify the columns as hidden. If we mark them as hidden, this won't appear in the select star statement whenever we query the table. So we can mark these columns as hidden. So I'm not sure why it is not taking, but yeah, we can mark these columns as hidden like this maybe. Yeah, this is the correct way. And in the end, you can specify not null. So guys, this is the correct way. You mark the columns as hidden. If you don't want them to appear on the general select star statement, you can mark them as hidden. All right, guys, we are done with the demo 5. Let's see how much we have recorded so that let me see if we can continue with demo 6. So demo 6 is regarding how you can insert a new data with visible period columns. I'm repeating again. Demo 6 is related to how you can insert a new data with visible period columns. So here we don't have hidden period columns, but we have visible period columns in this demo. And what we'll do, we will insert our new data into the table. So let me see how long will be this demo. Let me decide whether to cover that in this video or not. Okay, I think we can cover it. We can cover a lot. All right, let's cover demo 6. Let me copy this and take you to the SQL Server. Let's open up a new query window. So here we are covering demo 6, how to insert new data with visible period columns. So if we talk about the data in a system version temporal table, if the data is modified using regular data manipulation language statement or DML statements, with one important difference, period column data can't be directly modified. So if we talk about the valid from column and the valid to column, so if we talk about these columns in the temporal tables, the valid from and the valid to, we cannot directly modify the data in these columns. Directly modify the data in these columns. All right, so data cannot be modified in these columns, and period column data cannot be directly modified, that we have discussed. So whenever we perform a data update, and if it's a temporal table, the previous version of each updated row is inserted into the history table, that we had seen earlier as well. Now when the data is deleted, and if delete is logical and the row is moved to the history table from the current table, the data is not permanently deleted. So if we are modifying the existing rows in the current table, the older version of rows will get moved to the history table, and if we are deleting the rows from the current table, the deleted rows will get moved to the history table. They do not get permanently deleted. So basically there are 2 points I would like to discuss here. So let me break it down. So we are talking about when the data is updated and the previous version of each updated row is inserted into the history table. So there are 2 points: when the data is deleted and when the data is updated. So these three are the important points. So whenever we update the data, the previous version of each updated row will get inserted into the history table, and whenever the data gets deleted, and if the delete is logical, the row is moved into the history table from the current table, and in this case the data isn't permanently deleted. So these are some of the good points which you can make notes of. Let me go ahead and talk about inserting the data, which is demo 6 here, how to insert new data with a visible period column. So guys, we have a department table created earlier. Let's see if we have some records in that table. So let's do select star from department. So if we query this table, we see that these 2 columns do not appear. Valid from and valid to columns are not appearing in the output. The reason behind that is these 2 columns are the hidden columns. That's why they are not appearing in the output. So this is a temporal table, guys, and this is the history.department, which is a history table maintained for this temporal table, and currently this table is empty, and maybe we will use this table for our demonstration purpose. When you insert new data, you need to account for the period columns if they are not hidden. First of all, let me alter this table and change the column to normal columns from the hidden one. So I need to use the alter table department statement. Let's alter the, and we should specify the schema as well, because we have a table department with the history schema as well. You should mention the schema. If you have duplicate table names under different schema, you should mention the schema name. All right, let's alter the column. So use the alter column statement. Valid to column. So guys, the code is this. I've used this code. Alter table. We are altering the dbu.department table, and we have altered the column valid from, which is a hidden column, and we have dropped the hidden parameter. And let me similarly do that for the other column as well, which is the valid to column, which is a hidden column. And then we will query on the table. We are dropping the hidden parameter that we have added to the table. Now let's do a select star from the debug.department table to see if we are getting any data. So data is not there, but we are just checking that we are getting all the columns, including the valid from column and the valid to column. We should be getting these as well, because we have dropped the hidden clause for this column. And let's execute. Now we have started getting these 2 columns. So right now the columns are visible, right? And let's continue with our practical, how to insert new data with visible period columns. So in this case, our columns valid from and valid to, these 2 columns are visible now after we have made these changes. So note down these statement, these are important. So we are getting these columns valid from and valid to. All right, and similarly, let's try to query the history table as well. So we have history.department table. Let's see if we are getting the columns, the valid from column and valid to column from that table as well. So yeah, in fact, we are getting the columns. All right, so we are good here. So let's continue with our practical here, which is how to insert the new data with the visible period columns. Here we are using the department table. So whenever you insert new data, you need to account for the period column if they are not hidden. So we have accounted for that. We have made them non-hidden, or we have made them visible. Let's insert new data with visible period columns, and we can construct our insert statement when we have a visible period columns as follows. So let me write some code. So let me show you how you can insert the data or new data into the visible period columns table. Write down the insert statement, which is insert into, you need to specify the table name. Please specify the schema as well, because we have department table under two schemas. So let's use dbo.department. Let's add in some columns. So we are specifying columns, not adding columns to which data has to be inserted. So let's use the department ID, right? And second column is, so department ID is the first column, right? Department name is the second column. So let's take department name. So department name. Let's take third column, which is manager ID, and the fourth column is period department ID. Let's take that one. All right. So these are the four columns we are inserting values into. And if you specify the column list in your insert statement like this, you can omit the period column. So we are not specifying these columns here because these take default values. And the reason we are omitting these columns, the valid from and valid to, is because the system generates value for these columns automatically. So we don't need to specify these columns. Now we are inserting values. So you need to mention the values parameter. So specify values and specify the values in bracket, whatever you need for these columns. So for department ID, I'm taking 10 as the value. And for department name, I'm taking marketing as the department name. So let's specify marketing as the department name. And for third column manager ID, we are taking 101 as the manager ID. And for paid department ID, I'm taking 1. So this is the data row I'm trying to insert into this dbo.department table. So let's quickly insert that row. So guys, this is how you insert the row into the table. And the values for valid from and valid to column should get fulfilled automatically, and we can check the department table by querying it. So we see that valid from and valid to columns are populated automatically, and we have just entered the values for these first four columns right here. So there is no need to specify the values for the valid from and valid to columns, but yeah, we can specify the period column values in the columns list in our insert statement as well. Let me show you one more example where we can specify. So we can specify the valid from column, but there is no need. System automatically manages the dates that are being entered into these two columns. But yeah, you can also manually enter the date if you want to. So let's take another example. If you are using our syntax like this, then what you need to do, you need to provide in the default here. And you can mention that via the default clause, so that you're specifying that the column should take its default value. So by default keyword, you can specify that. So this is how you can insert the data. Let's try to insert a data row. Let's take 11, and instead of marketing, let's take sales department, and rest of the data is same. Let's execute this statement. We should be able to enter the second row. And we have taken the default constraints for valid from and valid to column. So it will put the default values for those columns. So this is the syntax in which we are taking the columns inside the insert structure. Then we need to specify the columns in the value section as well. So this is another way to insert the data. So we have inserted the data. Now there should be two rows of data inside this table. Let's query this table. So we have two data. And in the second row, we have specified the default constraints for valid from and valid to columns, and it has taken dates automatically, we have seen. All right. So, and in case if you don't specify these two columns here in the insert statement, we can still specify the default for these two columns. So another way is this. So if we don't specify any columns over here, we just mention the table name. We need to supply the data in sequence, what is present here on the left hand side. So first, starting with department ID, we have department name, manager ID, period department ID, valid from, valid to. Another way to insert data is this. So this is the third way. Let's take another row. So this time let's take 12, and the department is the production department here. Let's take production for the department. Rest of the items are same. We are taking default for the valid from and valid to calls. As per the ordinals, we are taking the value right in the sequence given on the left hand side. It's in sequence. So let's execute this statement to insert the values. So one more row is inserted, and we can check the data out here. So third row is also inserted, and it has already taken the default values for the valid from and valid to columns. So guys, we have shown you three ways you can insert the data into a particular table where we have visible valid from and valid to columns. Now this demo is done, guys, and if we come back to notes, we are done with demo 6. Let's see how much we have recorded. It's 52 minutes of video. Let's see how much is the demo 7, how much big it is. So in this demo 7 now, demo 6 is completed. In demo 6, we have shown you how you can insert new data with the visible period columns. Demo 7 shows you how you can insert data into a table with hidden period columns. Now let me go ahead and go to SQL Server and create a new query window. So let's cover demo 7. After that, we are done with this video. We are covering till demo 7. So let's create a table over here. So mention the create table statement. And here the table name is tbo dot company location is the table name we are creating. And we are making this table a temporal table, right? It's not a simple table, it's a temporal one. So I'm taking the location ID column, and this will be an integer type column, and it will be of identity type so that it can automatically fill out the column. And we are specifying the start and seed values here, and we are specifying that this will be a not null column and this will be a primary key column. So we have mentioned that. So this is the first column definition. Let's take location name now. So loc name is the second column, and this will be a varchar 50 data type, and this will not be a null column. Let's take city as another column, and let's again take varchar 50 as the data type, and this will also not be a null column. And let's correct the code here. All right, next column is valid from column. This is for making the table a temporal one. So valid from, this will be of date time type 2, and we need to mention generated always as row start, specify it correctly. So mention generated always as row start, and this will be a hidden column. So we are making this column hidden explicitly, and this will be a not null column. Similarly, we will take another column. Let's copy out this row, and another column will be a valid 2 column. So change it to valid 2, and here instead of start mention end, and rest of the items are same. And we need to specify the period. So specify the period clause here, period for system time, and specify this as argument, the valid from column and the valid to column. All right, these are specified, and we are done with the table structure definition, and we are good here. And later on, we need to turn on the system versioning. So you need to specify the with clause, and you are turning on the system versioning here. So system versioning is being set to on. Versioning is the correct clause. So you're turning on the system versioning, and we are executing this code. However, you see here we have not specified the history table over here. So let's see if it creates the history table on its own or not. Let's try to first execute the statement to create this table. So we have executed this statement, which has created a temporal table, although we have not mentioned the history table over here. Let's see if it has created any history table. So let's refresh the table section under the My Adventure Works, or in your case, it will be AdventureWorks 2022. So the table we have created is company location, which is this one. It's a system version table or a temporal table, and it has temporarily created a history table. So in case you don't specify the history table name, it automatically creates a temporary history table over here, right? With a similar structure to that of company location table. Now, all right, let's see the columns for this table. Now let's try to add some values into this table. So you start with the insert into clause, insert into, and you need to specify the table name, which is tbo.company location. That's the table name. And you are inserting values. You need to specify as per sequence. So first column is the location ID, but it's an identity column, so you don't need to specify the values for that column. For location name and city, you can specify the column values. All right, so let's specify for location name as headquarters, and for city I'm specifying New York. All right, so let's try to insert the value. And then in this case, the columns are hidden. These period columns are hidden, so we won't be able to see them when we query the dbo.company location table. So let's execute this statement. So we have inserted data into this table. However, if we query this temporal table, right, we won't be able to see the valid from and valid to columns because they are hidden. If you want to make them non-hidden, you can do that. So here we are getting only 3 columns, not the other 2 columns, valid from and valid to, because they are hidden. So this is the way you can insert data into a temporal table with hidden valid from and valid to columns. So this was demo 7 and we are done with that. How to insert data into table with hidden period columns. Period columns are valid from and valid to. Now in our next demo, we will start off with how you can insert data using a partition switch into a temporal table. So we'll talk about what is a partition switch in the next video. And we will try to cover this demo, how to insert data using a partition switch and how to update the current table. We'll talk on that as well. We'll talk about updating the data in the current table and how you can update the current table from the history table as well. You can do that so as well. So we will try to cover 2 or 3 demos in our next videos on the temporal tables, which will be video 4. This is video 3 of this video series. So watch out, keep an eye for video 4. It will be released soon. If you haven't subscribed to the channel, please go ahead and do so. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos and also the videos on the video series temporal tables. If you want to get notifications, please do subscribe. Let me give you 5 seconds. Please go ahead and subscribe right away. So guys, I hope you must have subscribed to my channel by now. And also let us know if you like this video or not. And in case you like this video, please hit on the like button below this video, which is coming below this video. Please hit on that like button. And also guys, do post in your comments, feedback and suggestions. We eagerly wait for your comments and would love to read the same. And guys, if you want to post in any comments to us, you can do so also on my email address, vrmavane@gmail.com. You can write emails to me as well. Apart from posting comments on the videos, you can also send me your emails with your comment, suggestions, requirements, feedback, etc. And we are done with this video. And guys, if you have a good network of friends, please ask them to subscribe to my channel if they are working in SQL Server domain or if they are working in data science domain. Also, it would be helpful if you can share my videos with them via the share button that comes below each and every video. You can use that share button to share my videos with your friends over any of the social media platforms. So help us here guys in spreading my channel and my videos to your friends. And I thank you so much for your time today on this video. And you have a wonderful day ahead guys. Thank you.